Good morning, students. Again, we are back to our course Electrical Circuit Analysis EE301, and we are in the module 6, that is two-port networks. Till now, we have covered 4 video lectures in two-port networks, and this is our 5th video lecture. And mostly, we have described about the two-port networks. There are two ports, and we have found out what are the open circuit impedance parameters, that is Z parameters, what are the short circuit admittance parameters, Y parameters, and we have found out the interrelation between the Z parameters and Y parameters, as well as we have described about the transmission parameters that are known as the ABCD parameters, and how they are related. Z is related to ABCD. All these things we have described, and we have found the detailed solutions of the interrelationship between the various transmission parameters, and the open circuit impedance, short circuit admittance, and the transmission parameters. And we have solved some of the problems. Again, to gain more confidence, let us solve another set of problems. Suppose this is the network, a very simple. This is a two network. This is a T network. Rather, you can see it is in the form of T, but there is a dependent source. What is the dependent source? It is a voltage source. What is its value? Its value is 2V1. By what value it is controlled? It is controlled by this value. Whatever this V1 will be there, this 2V1 will be acting accordingly. This is the voltage source. And a capacitor is there, an inductor is there, and we have covered from the time domain to the S domain. Capacitor 1F can be written as, in the S domain means frequency domain. So 1 by Cs. C is 1, so C value is 1, so 1 by S. In the S domain, resistor remains same, and the inductor 1 Henry becomes S. Now let us find out what will be the, let us calculate the Y parameters, and we know that the Y parameters are related like this: I1 equals to Y11 V1 plus Y12 V2, and I2 equals to Y21 V1 plus Y22 V2, isn't it? So this is the relation. So let us find out what equations we are getting. Let us take this loop. This is loop 1, and let us take this loop 2, and we will be here. So this, from here, I2 is coming, I1 is coming, both injecting into this part, and here the return path is I1, here the return path is I2. It is matched properly. So let us see V1 minus I1 into 1, that is I1. Then here, what is the voltage source? We are writing the KVL equation. So I1 into 1 means I1. So here it is becoming 2V1, and here you will be writing S into I1 plus I2. Minus, with minus, because the current is coming here, so plus to minus is minus, S into I1 plus I2, and the circuit is completed, and this becomes our equation 1. So let us solve it. V1 minus 2V1, so this becomes minus V1 minus I1 minus S I1 minus S I2 equals to 0. So what, making I1 as the subject of the formula, so you see everywhere it is minus, so all you can make it plus, and you can write I1 into 1 plus S, that becomes equal to that you can write I1 1 plus S I2 equals to minus V1. So in terms of, I1, what you can write, so I1 is equal to minus V1 minus V1. So this is V1 minus V1 minus S I2, isn't it? By 1 by S. So I1 equals to minus V1 by 1 by S, and that side it becomes so S by 1 plus S I2. So still we have not got, because I1 equals to Y11 V1 and Y V2. So I2 is coming. So let us see another equation. So it is all the KVL, KCL interrelationship, and you have to get it. I have rubbed this part, and let me see in the book. Yeah. So this was your diagram like this. This one is your one, this one. So I have rubbed the diagram. So that becomes the problem. So here it was your 1 farad, and this was the circuit diagram. So this one was your V2 V1, and this one is your V1 plus minus, and this one is your 1, this one is your 1 Henry, so that you can write as S, and here you can write as 2 V1, it has been given, and this one is your 1 farad, means 1 by S. So we have written, so here it was your I1, here it was your I2, here it was your I1 plus I2, both the currents. Now take this loop. So KVL for the loop 1 we have written, now for the loop 2. So this is for the KVL loop 1. So KVL for the loop 2, what you will be getting? So V2 minus 1 by S I2 minus 2 V1 minus S into I1 plus I2. Simplify it. So what you need, you have to eliminate I2, isn't it? So from this equation you can get what is your I2 and substitute the value here. This is very easy part. 1 by S, only the equation juggling is there. So 2V1, so all that is going to the right hand side, plus SI1 plus SI2, isn't it? So you can write, so V2 equals to 1 by S plus SI2. So this over plus SI1 plus 2V1. So what is your I2 from here? So I2 becomes V2 minus 2V1, V2 minus 2V1 minus SI1 by 1 by S plus S is equal to I2. So now you just write here in place of I2 this. So what you will be getting? So I1 equals to minus 1 by 1 plus S into V1. So here just here this is minus 1 by 1 plus S V1 V1 minus S by 1 plus S into I2. Now what is I2? I2 you can write as here V2 minus 2V1 minus SI1 by S plus 1 by S. Isn't it? Isn't it? S plus 1 plus S. So again I am rubbing the whole scenario. I'm rubbing, and I will be just explaining you about this. So, excuse me. So so finally what you will be getting, I1 equals to minus 1 by 1 plus s v1 minus s by 1 plus s by 1 plus s divided by s plus 1 by s. So this thing you must be very much aware. So this is a fraction, and v2 minus 2v1 minus si1. So make I1 as the subject of the formula. V2, yes, this is V2. V2. So obviously I1, V1 and V2. The only terms are there. Only terms, you simplify this, and I think you can easily get in terms of I1. So if you simplify this, what you will be getting? If you simplify this, the upper numerator part is s by 1 plus s divided by, so what will be the LCM? LCM will be s, 1 by s means s square plus 1. So this becomes s by 1 plus s into s by 1 plus s square. So this becomes s square by 1 plus s square by 1 plus s. So this thing you can write as this one. Let it be as k. Okay. So to simplify this equation, so I1, and you think this as alpha. So minus alpha v1 minus k into v2 minus 2v1 minus si1, where k is this one, where k is your this one, and alpha is 1 by 1 plus s. So so what you will be getting, I1 equals to minus alpha v1 minus k v2 plus 2k v1 plus k s I1. So you can take common here, 1 minus ks, 1 minus ks into I1. You are taking this one. So uh, so v1 you can take common, 2k minus alpha v1, this part and this part gets this one, minus k v2. And if you divide by 1 minus ks, so this part gets over, this part gets over, and this part 1 minus ks. So you can directly say I1 equals to y11. So what is y11? Y11 becomes 2k minus alpha by 1 minus ks. Now k value you know, and alpha value also you know. You substitute and you will be getting in terms of s, and if you know k and you simplify y2, so you will be getting this as your y12. So this is the procedure of solving this type of problems, because you can't do it otherwise, because there is a dependent source. You have to take the KVL and KCL equations, no other way. So let us, this is a little bit mathematical juggling part is there, and let us do some other sort of very interesting problems, and you will be very much clear of this function. Suppose a network is given, a network, you don't know what is happening here inside a network, a black box. this part is given. This is your 2 ohms, and this is your it is been given 1 ampere. Okay, now here it is connected with a half ohm resistor, and here it is connected with a 1 ohm, and here it is being connected like this, and here it is 2 prime 2, and here it is, this is a node junction point. This is 1 prime, and this is your V1, and this is your V2. Here it is I2, here it is I1, and here it is 2 ohms, rather you can say it is 2 ohms, and here it is half ohm. So it has been given here, I am writing the Y parameters. Y11 has been given, and Y11 equals to Y22 has been given as 2 mho, and Y12 and Y12 has been given as 1 mho, and Y21 has been given as 2 mho. So now the network N, for N, all the Y parameters have been given for the network N. For network N, this sort of parameters are given. What is happening inside this? The network has been given. It has been asked, find the voltage V1 and V2. You have been asked to calculate what is the voltage V1 and V2. What is the value of the numerical value of the voltage V1 and V2? So how will you do it? Very easy, very easy. Write the KVL. So this up till here you know. Up till here you know very well what is the interrelationship. You can write I1 equals to Y11 V1 plus Y12 V2, and I2 equals to Y21 V1 plus Y22 V2. So from here, what you can write? You can write I1 equals to, what is the value of Y11? 2 V1 plus Y12 value is 1 V2. And similarly, I2 value is Y21. Y21 is how much? 2 V1 plus Y22. Y22 is how much? 2. So 2 V2. So this becomes your equation 2. This becomes your equation 1. From the network we determine. Now you can see this current. This is a independent current source of 1 ampere. This current will flow here. This will come here. This will come here. This will come here. You can apply KCL at the node P. Let applying KCL at node P. Apply. So this current entering, this is leaving, this is leaving, this is leaving. Very easy. First you apply the current. So what is the current entering? So 1. So entering current should be equal to the leaving current. So entering current is 1. What is the leaving current? Leaving current is this one. What is this magnitude of the current? What is the potential here? V1. So this potential means this potential. So V1 by 2. So V1 by 2. So this is the amount of current. Now what is the current here? The current here is given itself. It is I1. The current here is I1. Now what is the current here? So what is this potential? This potential is V2, means this potential is also V2. If this is V2, this is V2. So this point, the potential at this point is V2. The potential at this point is V1. This is V1. This point is V1. If this is V1, this is V1. So this point potential is V2. As the current is flowing from this node to this one, so what is the difference of the potential? So V1 minus V2. This is the difference. What is the resistance? By half. So by half means you can write directly E multiplied with 2. multiplied with 2. So this is becomes the third equation. This becomes the third equation. Now applying KCL at the point N. Suppose I will be applying KCL. So this current is I2 is going here. This current is this one, and this current is coming from this side. So applying KCL at node M. Applying KCL at node M. So what you will be getting? So this current is entering. So entering equals to all leaving. So V1 minus V2 by half means multiplied with 2. This current should be equal to this current. What is this current? V2 by 1. So you can write as V2 by 1 this potential. And what is this current? This current is given, that is I2. So this is our equation 4. So all these equations will help you to get the values of V1 and V2. I am rubbing this diagram. Now I got the equations as far as possible. What is not necessary now, I am rubbing it. Very interesting problems. So simply manipulating, so what you can write, 1 is equal to V1 by 2 plus, now what is I1? I1 is equal to 2V1 plus V2, and this becomes 2V1 minus V2. So it implies 1 is equal to all V1 you write V1, 2V1 plus here also 2V1 and here V2 minus 2V2. So minus V2. So you will be getting 1 is equal to 2 plus half, that is 2.5. 2.5, 2.5, 2 to 4 and half, 4.5 rather you can say. It is 4.5 V1 minus V2 under simplification. And from this equation, what do you get? This is our extracting equation. And from this equation, what do you get? 2 V1 minus V2 is equal to V2 plus I2. What is I2? I2 is nothing but 2V1 plus 2V2. I am rubbing this, all these things. So it implies 2V1 minus 2V2 plus V2, 2V1 minus 2V2 is equal to V2 plus 2V1 plus 2V2. So what equation you will be getting? So this 2V1 gets cancelled. So 2V2, and here also it comes 4V2, 2V2, 3V2, 3V2, and this side it becomes 0, 5V2. So it implies V2 is equal to 0. Directly you are getting V2 is 0. It implies, so V1 equals to 1 by 4.5. 4.5 means 9 by 2. So that becomes 2 by 9 volts, and V2 is 0. So this is the answer of this question. So V2 becomes 0 volt and V1 becomes 2 by 9 volts. So these sort of problems are very interesting and you have to tackle in this way. Let us solve another set of problems. Let me discuss so that you will be very much interested to know such types of problems. So suppose a bridge network, how to tackle it? Suppose this one. How to tackle this sort of problems? So this is your V2, and this one is your I2, and sorry, straight line not drawn perfectly. So this one is your V1, and this one is your I1, and this is your black box. This is your box. Here something is there, and that something has been also told. 4 ohms. This is 2 ohms, 3 ohms, 1 ohms, 2 ohms, 3 ohms, and 1 ohm. Okay. You have been asked to find out the Y parameters. Y parameters of the network. Y parameters. Now remember one thing very nicely. A pi network, if you convert a network, suppose a network is there, a pi form, if you convert any sort of network to a pi form, this pi form, pi network, you can easily get Y parameters. Convert this network in this pi form. You can easily get the Y parameters. How? Y11 will be this mho plus this mho. This mho, this admittance plus this admittance. Let it be Y1, Y3 and Y2. So Y11 will be addition of Y1 plus Y2. Similarly, Y12 will be negative of Y2, and Y21 will be negative of Y2, and Y22 will be addition of these two, that is Y2 plus Y3. So simply the admittances, all the modes you have to arrange in there. That gives only in the pi form. If you convert the network to pi form, it is very easy to get Y parameters. Now, if you convert the network into a T form, this is a T form, where suppose this is Z1, this is Z3, and this is Z2. This is a T network. If you convert any network to a T network, this is T form, it is very easy to get the Z parameters. And vice versa, if you know the Z matrix, you can inverse it and get the Y matrix. So Z matrix Z11 will be Z1 plus Z2, these two. Similarly, Z12 is Z2, and Z21 is also Z2, the common part, and Z22 is equal to Z2 plus Z3. So this is the fundamental concept behind this, and I think you can try this one and you will be getting the answer. So I think I am little bit discussing about this. You convert, you see, this is a T network. This is a T network, isn't it? This is a. Can't you convert it into pi form? Can't you convert this into pi form? Obviously, a star can be converted into delta. So that's what I am asking, that a delta, this is a delta, you convert this into T into delta. So once you get this value, and this value, these two becomes parallel, and this one remains and this one remains. This means this, you get this, you get this, you get this. Inverse those. All individually inverse, you do it and add it, and you will be getting the Y parameters very quickly. Okay, thank you students for your patient hearing. We will be continuing in the next lecture. Thank you.